In this video, we are ready to talk about measures of spread or dispersion of data. So, generally, when you collect a data set, there is a particular data value that is very typical. But then, not all values are going to be the same, else you have a constant data that truly holds no information in predicting variability in your data. So, if there are other values that vary away from what is typical in your data set, we need a measure that measures how far they vary away from what is typical in your data set. The tool we use in statistics to measure that are called measures of spread, dispersion, and examples of such measures are standard deviation, and it is the most common measure of spread and one of the most important. It is a number that measures how far data values are spread away from the mean, assuming the mean is the typical value here. Now, your standard deviation is at least 0 or a positive number. It must never be negative. And a large standard deviation shows that your data values are more spread out from the typical mean value, whereas a small standard deviation indicates that your data values are more concentrated towards or close to the mean or typical value. A data set where you have a small standard deviation is desirable because it is more controllable, more relatable, and more predictable. So how do we compute the standard deviation? We take a small example. We have the numbers 1, 2, 4, and 5 in a single data set. It is a sample that has been taken from a larger population, and our goal is to compute the standard deviation by hand. This is what we do. Step 1, we compute the sample mean. We're going to compute the sample mean represented by x bar, and that will be done by adding all four numbers together and dividing by 4, which will give 12 divided by 4, which is equal to 3. So, take notes, our sample mean x bar is equal to 3. So, this x bar here is the number 3, the average of all of these values. The next step is to get the deviation of each value. Say 1, how far is it away from the typical value? So you have 1 minus 3, that will give negative 2. Then how far is 2 away from the typical mean value? That will be negative 1. Do the same for the rest. 4 minus 3 is 1. 5 minus 3 is 2. And so the next step would be to square each of your answers for deviation. For example, the first deviation here is negative 2. We're going to square it, we get 4. You have negative 1 square, you have 1, you have 1 square, you have another 1, then 2 square, we have 4. All of these deviations, according to the formula for the standard deviation, so we are almost there. Standard deviation, which I'm going to, for the sample, so I'm going to call it sample standard deviation, which we represent in statistics by lowercase s. It will be the square root of the sum of the squared deviations. So 4, 1, 1, 4, divided by, how many data values do we have? We have 4 of them minus 1. So this is equal to the square root of 10 over 3, and this will be approximately equal to s equals 1.8257. This is how to compute the sample standard deviation. In this class, you will not need to compute this by hand, but for intuitive assistance, it is always good to show you how these data values or measures are obtained. We are going to use StatCrunch, which is technology, to do all of this for us. Officially, the formula for the sample standard deviation is given by this. But I figured this is of no much use. What is of major use is what we showed earlier. Then, if we have a sample standard deviation, we also have a population standard deviation. The key difference being that in the population standard deviation, we do not subtract 1 from the denominator, whereas in the sample standard deviation, we do subtract 1. And that is based on a property known as bias of a statistic. So that will be reserved for a higher class in statistics. Let's take an example of using technology now to compute standard deviation and other measures of spread or dispersion in your data. These are also called measures of variation, so please note that in passing. In this example, we're told that a random sample of 20 pledges to a public radio fundraiser reviewed the dollar pledges in the dataset pledges. We will see that dataset in a bit. We're to complete parts A and B below. We'd like to find the range, the sample variance, the sample standard deviation, and the interquartile range. To clarify, the range is always the maximum value minus the minimum value. The sample variance is the square of the answer observed for the standard deviation. So if you get the standard deviation first and you square it, the resulting answer is called the sample variance. And the sample standard deviation is, we're going to get the answer too for that. And we would also like to find the interquartile range, which is Q3 minus Q1. So let's go into StatCrunch and see how to get all of these values. Here in StatCrunch, I have the data on the pledges, and I would like to go to Statistics, Summary Statistics for data in a column. The data is stored in the pledges column, and I would like in particular the following measures of variation or spread. I would like the variance, and I would like the standard deviation. I would also like the range, and I would like the interquartile range. So I'm going to compute that. So I have all of the data values here. I will take that to my working bench. So based on the technology output, we have the range, the biggest value minus the smallest value, which is 105, the sample variance, which is the square of the standard deviation, is 770.78947. The sample standard deviation is 27.763096, and the interquartile range is 30 or 30. Question B. Briefly explain the difference between the standard deviation and the interquartile range as a measure of dispersion of spread. Besides the formula difference, so your standard deviation, we saw the formula for that earlier, and we also saw all of the sequence of steps to compute the standard deviation earlier. We also have that the interquartile range is computed as the upper quartile, Q3 minus Q1. At the same time, you should also note that we use the standard deviation as a measure of spread when the distribution is symmetric, and the interquartile range is advised as the appropriate measure of spread when the distribution is skewed. This is very important to note. Then, how should you, a data analyst, report your findings to describe the distribution of dollar pledges in this data set we have considered? To describe the distribution, my first step would be to go back to StatCrunch. I'm going to close this, and I'm going to graph using a histogram the variable pledges, compute. What I see here is an approximately symmetric distribution, since I don't see a longer tail to the left or to the right. So, with that said, I am going to report the mean, since the distribution is symmetric, and based on what we just said, since the distribution is symmetric, I'm also going to report the standard deviation. So the mean for the measure of center of what is typical and the standard deviation as a measure of spread. In other words, since the distribution of dollar pledges is approximately symmetric, I report the typical pledge amount of the mean of $74.50 and a standard deviation of $27.76. This table summarizes the idea of what we're talking about. If the distribution is symmetric, we report the mean as the central tendency measure and the standard deviation as a measure of dispersion. If it is skewed, we use the median as the measure of central tendency and the interquartile range as the measure of dispersion. We now proceed to another type of measure of variation, and that is coefficient of variation. The sample coefficient of variation is simply the sample standard deviation divided by the sample mean. So you see, when the coefficients of variations for two or more distributions are compared, the distribution with the largest coefficient of variation is said to have the greatest relative spread to the center of measure. So, we take a question here. In finance, the coefficient of variation is one measure of the relative risk of a stock portfolio. Assume portfolio A has a collection of stocks that average a 12% return with a standard deviation of 3%, and portfolio B has an average return of 6% with a standard deviation of 2%. Compute the coefficient of variation for both portfolios and state which is more risky. So, to begin, we're going to look at portfolio A, and we're going to look at portfolio B of investments. The average for portfolio A is 12%, so X bar is 12%, and the standard deviation is 3%. So the coefficient of variation will be standard deviation 3 divided by 12 multiplied by 100%, and that will give 25%. On the other hand, for portfolio B, the sample mean average is 6%, and the sample standard deviation is 2%. So the coefficient of variation will be 2 divided by 6 multiplied by 100%, and that will be equal to 33%, approximately, or 33.3%, if you will. Well, it appears that portfolio B has a greater coefficient of variation. Take note, since that indicates that it has more spread, it means it is more variable or less predictable, and so it is more risky. So, even though portfolio A has a lower standard deviation, portfolio B rather, even though portfolio B has a lower standard deviation, it might be considered riskier than portfolio A because B's coefficient of variation is 33%, which is higher than A's coefficient of variation, which is 25%. With that completed, we proceed to the next example. Here we're told that a random sample of 12 tests for two different drugs reviewed the following times in minutes until the effects of the drugs were neutralized. And we're going to see that data in a little bit. Our goal is to first compute the mean and standard deviation for each of the two drugs. So let's see. Here on your screen are the two data sets for drug A and drug B. I'm going to go to Start, Summary Stats, go to Columns, and I would like to work on the data set for drug A and drug B. Okay, let's pick that again. And I would like, just based on the question, just the mean and the standard deviation. So I'm going to grab that too, mean and standard deviation. Okay, so compute. and I am going to pull this up. So I have the mean and the standard deviation. Here on your screen, you will see the summary of the mean and the standard deviation for each of the two different drugs. For example, for drug A, the mean is 235.8 and the standard deviation is 14.2. For drug B, the mean is 270.5 and the standard deviation is 21.6. So, question B. Based on the sample means computed or calculated in part A, which drug appears to be effective for longer? Well, considering the typical or mean values here, we can say that drug B appears to be effective longer because it has a larger mean number of minutes of effectiveness. What I just said is what I have just written down here for you. Now we proceed to question C. Based on the sample standard deviations calculated in part A, which drug appears to have greater variability in effect time? Well, considering the standard deviation for drug A, which was 14.2, and that of drug B, which is 21.6, we can say that drug B appears to have the greater variability in effect time. The conclusion is based on the standard deviation of drug B, which is 21.6, larger than 14.2. Let's write that statement down. So, again, what we just said is what we have written down here, namely that using the sample standard deviations, drug B has the greater variability in effect time since it has the bigger standard deviation.